In today's math lesson, we're going to solve equations with variables on both sides. When solving for x, I strongly encourage you to draw that river through the equal sign to clearly distinguish between the right and left sides of the equation. It's really very simple, but extremely helpful. Now, if you have variables on both sides of the river, you're going to pick one, and truthfully, it doesn't matter which one. Just pick one to move to the other side of the river. Just like when moving numbers back and forth across the river, you're going to do the opposite of the adding or the subtracting to get that variable term over there to the other side of the river. Afterwards, you're going to just proceed like normal to solve for x. So here we go. Example 1. Solve for y, where 5y equals -6 plus 6y. So this is where choice becomes something you get to have. We have 5y on the left side of the river and 6y on the right side of the river. And we need to pick one to move to the other side of the river. Either 5y has to go to the right or 6y has to go to the left. Remembering that your goal is to get all of your variable, all of the y's, to one side of the river away from any constant terms. That's the goal. So if I want to get all of the y's on one side of the river away from this -6, then the shortest, fastest way to get there would be to subtract over this -6y. It is adding in the problem, so I do its opposite. I'm going to subtract it. And what you do on one side of the river, you still do it to the other side of the river. So the purpose in this was to get rid of the 6y so that all of the y's are on the same side of the river. If you had chosen to move the 5y first, that would be just fine. Your steps would look a little different than mine, but that's okay. All right, so 5y minus 6y will give you -1y. And that equals -6. Okay, so now this looks very simple because it is. We just need to get the y, now that it's essentially alone, we need to get it positive. Remembering that a letter and a number, a variable and its coefficient side by side are multiplying, we're going to do the opposite of multiplying, which is to divide. And what you do on one side of the river, you still have to do to the other side of the river. The whole point of that was to make our y positive so that those -1s cancel out. And that leaves us with y equaling the quotient of -6 and -1, where -6 divided by -1 is equal to +6. And there you go. Example 2. We're going to solve for s, where -8s is equal to -s plus 7. So we look at our problem and we say, okay, well, I've got s's, I have variables on both sides of the river. And we need to pick one. We need to move one to the other side of the river so that we have all of our like variables on the same side of the river. Remembering that our goal is to get it alone, away from the constant term. So I would suggest, although it is not required, that you would move this -s that's on the right first. Do you have to move the -s? No, we could have moved the -8s. And that's not bad, it's not wrong. It's just setting you through a different set of steps, and that's fine. So we're going to move this to the left side of the river by doing its opposite. Right now it is subtracting, the opposite of which is adding. And what you do on one side of the river, you definitely have to do on the other side of the river. And we did that to cancel out the -s. Okay, we know that negative 8s plus s is going to equal negative 7s. And we know that because there is an understood 1 in front of that s. So in case you're wondering where that negative 7 came from, negative 8 plus 1, well, yeah, that's equal to negative 7. Okay, equals our constant term of 7 that's here on the right side of the river all by itself. Now that I've gotten rid of constant terms and I've gotten all of my variables together, let's finish this off and get this s alone. A variable and its coefficient side by side are multiplying, the opposite of which is dividing. And what you do on one side of the river, yes, you definitely do to the other side of the river. The whole purpose of that was to cancel out those negative 7s there on the left, leaving you with s equals the quotient of positive 7 and negative 7, where 7 divided by negative 7 is equal to negative 1. And there you go. Example 3. We're going to solve for p, where 3 plus 2p is equal to p plus 8. As we get started in this problem, you see clearly that we have p on both sides of the river. I usually like to refer to this variable as a piglet. I couldn't tell you why, I just do. So 3 plus 2 piglets equals a piglet plus 8. And we have to get all of the piglets onto one side of the river. Again, you have choice. Suggestion: move the smaller variable across the river. The only joy that this brings you is you are less likely to have to deal with negative numbers. It's not a fail-safe, but it's hopefully helpful. So this piglet here on the right is currently positive. So to move it, let's make it negative. And what you do on one side of the river, you definitely do on the other side of the river. And the whole purpose was to cancel out the piglets that are there on the right side of the river. This gives us 3. And how many piglets? Well, this is an understood minus 1 piglet. Okay, so 2 piglets minus 1 piglet, that is 1 piglet, equals the 8 that is on the right side of the river. Great. Finally, this is nice and easy. We need to just subtract over this 3 as it is currently positive, so its opposite is subtracting. And what you do on one side of the river, of course you do to the other side. And this gives us piglet is equal to the difference of 8 and 3. So 8 minus 3 is 5. And there you go. Example 4. We're going to solve for g, where negative g plus 7 equals negative 4g minus 5. Well, just for something different, I thought we would go ahead and move the g that is on the left to get this problem started. You could most definitely move the one that's on the right, but we've moved a lot of things from the right to the left, so I thought we would go ahead and move from the left to the right. It truthfully does not matter. Now, we do this, as always, by using our opposite sign. Currently, this is a negative g. So its opposite is to add g on both sides of the river. And just like normal, the whole point of this was to get all of the g's, or the giraffes, as we might say, onto one side of the river. So this gives us 7 equals, let's see, negative 4 giraffes plus 1 giraffe, as it is understood that that is a 1, is equal to negative 3 giraffes minus 5, as the minus 5 was sitting there waiting to be used. Okay, now that all of the giraffes are on the right side of the river, let's get them alone. We do that by removing the term that is just a constant, that is only purely adding or subtracting first. The opposite of subtracting is still adding. And what you do on one side of the river, yes, you definitely do that to the other side of the river. And that whole point was to make those 5s cancel out. So now the sum of 7 and 5 added together make 12. And that is equal to -3 giraffes, as we were stating. And last but not least, we just get rid of this g. Well, we get rid of the -3 that is with the g. We get the g all alone by dividing. That's right, because a letter and a number, a variable and its coefficient side by side are multiplying. And the opposite of multiplying is dividing. And what you do on one side of the river, you definitely have to do to the other. And the whole purpose of that was to cancel out your -3s. And you know, because you're smart, that a positive divided by a negative is a negative. 12 divided by 3 is 4. And -4 is equal to g. And there you go. For our 5th and final example, we're going to solve for z, where -8z minus 3 plus 8z is equal to z minus 10. Now this problem might look really scary to begin with, but truthfully, it doesn't have to be at all. Let's see. We learned in a previous lesson that when you have the same variable on the same side of the river, that you should go ahead and combine them. And don't you know it? We definitely have them here on the left side of the river. So you can even rewrite this just to help your brain organize its thoughts as -8z plus this other 8z minus the 3 equals z minus 10. We haven't done anything yet except to help organize your thoughts. That's all we're doing. So now we can see that when you combine the -8 plus 8, well, that cancels out, right? Because -8 plus 8 equals 0. So that was just kind of a fluke. As a result, you have -3 equals z minus 10. Oh, well, that's a very simple, very small little problem. All we have to do to get z alone is add 10. And because right now it is subtracting, the opposite is adding. And what you do on one side of the river, of course you do that to the other side of the river. Your 10s on the right cancel out, leaving you with -3 plus 10 equaling 7. And that is our value of z. And there you go.